welcome to the percent composition review. Just going over the basics of percent composition from, this is nothing really beyond Regents chemistry, just a reminder in case it's been a little while, which is perfectly fine. Percent composition. Percent composition is defined as the percent by mass contributed by each element in a compound, and it really is important that you understand that we look at percent composition as percent by mass, not by moles. Yes, we tend to do nearly everything in chemistry with moles, but percent composition is something that's not done as much. So it's considered percent by mass. And there are a couple different ways that we can calculate percent composition. You can calculate it from mass information, like from lab data information, which I have a sample problem to go over. And you can also calculate it from gram formula mass. Fundamentally, though, it boils down to this formula right here, part divided by whole times 100. That's just, in general, any percent. The part, you can get the part any number of different ways, you can get the whole any number of different ways, but it's fundamentally part divided by whole times 100. So looking at the first problem, calculate the percent composition of nitrogen in calcium nitrate. Here's an example, because the problem didn't give us any empirical lab data, that we're going to get this from the gram formula mass. But again, Mrs. Julian is a little bit tricky. She doesn't give you the formula for calcium nitrate, which means that we have to figure it out. So, a little bit of nomenclature. This is the sort of thing that I will be expecting you to do in this course. Calcium nitrate. So what's the formula for calcium nitrate? Well, calcium, that's easy. That's Ca. Where is it in the periodic table? Because we have to figure out charges. It's group 2, 2 valence electrons. It's going to lose those two, so it's got a charge of +2. Group 1 is +1. Group 2 is +2. Nitrate, 8. That's a polyatomic ion. That's a polyatomic ion that I asked you to memorize. Nitrate is NO3, but you can't just memorize the number of atoms. You also have to memorize the charge. Charge on nitrate is -1. So do the crisscross method. Calcium is +2. Nitrate is -1. That means that we're going to need 2 of the nitrates to cancel out the +2 charge from the calcium. Great. Why are we doing this again? Because we need the GFM of this thing in order to figure out the percent composition. So gram formula mass of calcium nitrate, you just add up the individual atomic weights of all the elements in it. So 40.1, that's for the calcium. Please do go to the 10th, have some self-respect. Do not round to the nearest whole number. Calcium is 40.1, not 40. 40.1 for the calcium, plus how many nitrogens are there? Remember, we distribute this 2 to everything inside the parentheses. So there are 2 nitrogens. Each nitrogen is 14.0. And then there are 6 oxygens, 2 times 3, distributing that 2. There are 6 oxygens. Each oxygen is 16.0. You should make sure you're doing this math along at home and you're getting the same thing as I am. 164.1 grams per mole. If I made an egregious mistake, please let me know and I will fix it on the video. Now, that is the whole thing. This is the whole. We want part over whole. Okay, so that's our whole. Our part, what is it asking about? It's asking about nitrogen. So the part is going to be the 2 times 14, because this is how much of this thing is nitrogen. This bit right there, that's the nitrogen bit, right? That's the Ca, that's the N, and that's the O. So that's the part. Our whole, we just found that out, 164.1 times 100. I get a percent composition of 17.1% for the nitrogen. That's using GFM. This next example is using mass data that you might collect in a lab. A 5.7 gram sample of an unknown oxide is found to contain 4.28 grams of titanium. Determine the percent composition for both elements in the compound. What are the 2 elements? We have titanium. Clearly, it tells us that. That's 4.28 grams. Both elements. Well, what's the other element? It's an oxide. It's an oxide right there. It tells us in the first thing. So that the other element has to be oxygen. Well, it doesn't tell us how much oxygen we have. That's okay, though, because we can figure it out. We can figure it out a number of different ways. Because we're going to look at this. A 4.7 gram sample of an oxide. And this thing right here, this is the whole. This is one of the parts. This is the other part. The whole thing is 5.7 grams. So why don't we figure out the percent titanium first, because we have all that information. Percent titanium, it told us that the part of it that is titanium is 4.28 grams. Easy. The whole thing weighs 5.70 grams. So just doing that math out, percent titanium, part over whole, you get a percent titanium of 75.1%. Figuring out the percent oxygen, number of different ways that you could do it. Realistically, at this point, the easiest way would be saying, all right, well, if the titanium is 75.1%, then the percent oxygen has to be 100 minus the percent of titanium, right? Because that's the way percents work. They're all taken out of 100. So the percent oxygen is going to be 100 minus 75.1. That right there, this first bit, not math I expect you to do in your head. The second bit is math I would expect you to be able to do in your head. 24.9% oxygen. Okay, so that's just using mass data. Same sort of way. We don't know the GFM of this compound, but that's okay. We don't need it because we know the mass of the part, we know the mass of the whole, and we can compare them. Next up is a little bit of a review of hydrates, because hydrates are very commonly seen in percent composition problems. Remember that a hydrate is something that has water attached, and that the water evaporates off when you heat a hydrate strongly, and it leaves the anhydrous compound behind, everything but the water. So, a question says, an unknown hydrate with a mass of 7.4 grams is heated in a lab. After heating, the mass of the anhydrous salt is 5.02 grams. What is the percent water in the hydrate? Key here is remembering that H2O evaporates from a hydrate. Leaves the anhydrous salt behind. We are looking for the percent water. That means that we need to know the mass of the water. We also need to know the mass of the whole thing. The whole thing is the hydrate. So the mass of the whole is right there, 7.40 grams, because this is the hydrate, meaning the water is inside of it. Now it says that we heat it up, and then we weigh it again, and the mass of the anhydrous salt is 5.02 grams. Remember that this word means no water, fundamentally. So this is not the mass of the water. This is the mass of everything but the water. So the mass of the water is going to be the whole minus what's left, right? Because the water evaporated. We didn't catch it in any way. We didn't hold on to it, so we don't have a direct reading for the mass of the water. But we can figure it out by saying, okay, when we started and the water was inside it weighed 7.4 grams. We heated it up, the water disappeared. Now it weighs 5.02 grams. So the difference has to be the mass of the water. So the water has to be the missing mass, 2.38 grams. Now the percent water becomes very, very easy, because we're just going to take that 2.38 grams, that's our part, divided by the whole thing, what we started with, all of it, the 7.40 grams, multiply it by 100, and we get a percent water of 32.2. Okay, so that's percent composition. That is definitely something that we're not going to talk about in class, but you will be required to use that at various points this year.